should do. Yeah, let's go. Oh, look, let's see if it's down here. I think I put it right down here. Let's find out. Where's the power series definition? It's here somewhere. Oh, look at that. Power series. Copy. Okay. Excellent. Here it is. Paste. Awesome. There it is. There's your definition of a power series. A power series about x equals a is a sum of constants times powers of x minus a. So you now know that it is a yes. So therefore, it's going to be a series of constants times x minus a. What's a in this case? 0, right? So in this case, what do you have? What is c not going to be? Oh, it's 0, right? So if you did this out, what are you going to end up with? You're going to end up with 0 plus 1 times x minus 0 plus 0x minus 0 squared, right? All the way up to, and then what do you end up with eventually? 1 times x minus 0 to the 7th. So it just turns out a lot of the constants are what? 0. A lot of the constants are 0. A lot of the constants are 0. Look, a power series about x equals a is the sum of constant times a power x minus a. We're right there.
But if it's going from 0 to 1 and 0, is that like...
These constants right here, you see these constants? They can be 0. So if it's 0, like this is a 0, so the next one's going to be 0, 0, 0, all the way up to this one. That's the first one where it actually is going to have something that sticks around. Because this changes, right? That changes. So therefore it's not the same. So therefore it is not a power series. Yes, Num.
Why does
4 is right there, yep. Hold on, Jerry's speaking. Yes, Jerry? Okay, nice. So we can do this in pieces. So P is going to be a part of this, like P is going to be in there. Anybody have an idea? You can, for example, these seem to fit a pattern, but the first one doesn't. How would you write out the first one so it would fit the pattern? Yeah, so there's over this 1 factorial, right? And then it's going to be P minus 1 to the 0 power. Just to make, so this thing right here is that right there. Do you agree? Just so you can see the pattern. So it's going to be the summation from n equals what? 0 to infinity. You want to start there? Sure. Okay. P times what? P times P minus 1. You have to be really careful on this one. So first we can do the denominator. What's the denominator going to be? N plus 1 what? Factorial, right? You have to be super careful. So first you have P, and then you have P times P minus 1, and then you have P times P minus 1 times P minus 2. You have to be super careful. How do you get that? It's factorial, but not all of factorial, right? So what are you going to have to do, Chip?
So if I did this, I had it from n equals 1.
You can do that. Let's just do it from n. We can do it from n equals 0. Let's do it from there, okay? You have. How do you get a factorial, but not all of it? You have to do what? You have to divide by another factorial. You have to divide by another factorial, right? So you're taking something and taking away. So a factorial is how many terms? A ton of them, right? If P is really big, it's going to be a bunch, right? But you want something that starts there so you can cancel out the rest. Oh, sorry about that. Do you understand what I'm saying there? So to get this, this right here is a partial like a partial factorial, the P, and then P minus. So, okay, so it's less and less and less. So it looks like this right here, how would you get just P? That would be P factorial, but what would you have to, I'm just going to try this. What would you have to put on the bottom in order to cancel out the rest? P minus 1 factorial, right? Do you agree with that? Yeah. But then that would be the same, but how would you get, but you need that P minus 1 to pop up in there? Like how do you get P times P minus 1? What is P times P minus 1? That's P factorial over what?
P minus 1 factorial.
P minus 2 factorial. You need the next one, right? And then what is P times P minus 1 times P minus 2? What's that right there? That's P factorial over P minus 3 factorial. Do you agree? Yeah. So it's not just P, it's not going to be, which number down here do we have to mess with? No, the n stays where it is. The end is by itself. P minus something. Oh, it's P minus something, right? So we're going to take this. So we're going to take this right here. Let's move it over a little bit. So it's not going to be P minus 1 factorial. What is it going to be? P minus n what? P minus n. So in that case, n is 0 minus 1 factorial, like that. Just one. We started at 0. You're right. If we started at 1, it would be a little nicer. But do you see what happens there, everybody? It creates this number right here, this minus that. What does it end up creating? It ends up creating that 2 and that 3. Do you see that right there? So this is new. You're right. This is a little different. You have to cancel out a whole bunch of downstream factorial pieces starting at a specific point. Good? Yeah. Where does this? 5 make sense? 0 means you have no idea what's going on. How do you feel about this right here? Pretty good-ish? Okay, one more. Yes?
Sorry, the book.
Yay. So what do we got here? We can do it in pieces, right? It's going to be x to, do you want to start at 1 or 0? What do you want to start at? 0 or 1? 0? Okay. 0 to infinity, so it's x to the what power? N plus 1. So we've just taken care of the x. Oh, I'm not highlighting. So we've just taken care of those, right? Do you agree? There's that point. So we have 1, 3, 5. 1, 3, 5. Now here's the thing. Sometimes the big kid way is much, much harder, and I'll be careful not to ask you ones that make it impossible. This one, yeah, it's easy to see. It's like, take as many odd numbers as there are, right? You have to be really careful about this if you want to do it the big kid way. So if we were to do it that way, let's try the denominator first. There's a factorial down there, right? What's the factorial that's easier to do down there?
N plus 1.
Yeah, there's that. The highlighter won't stick for some reason. It really doesn't like to stick. Okay, let's try it again. There you go. Come on, there you go. There's this right here, and we could also write it as 1 factorial right there, right? So we end up with n factorial, n plus 1 factorial. Nice. So we have this. Exciting. Nice. Okay. So then we have 2 to the what? 2 to the 2 to the n plus 1. Like this. Nice. We're getting there. Let's go to green. It'll stick with green. Is it sticking? There it is. So we have these terms now. So the only thing left is odd numbers, right? So how do you do it? Let's just write down at the table. What does 0 correlate to? 0, we want 1. At 1, we want 1 times 3, right? At 2, what do we want? 1 times 3 times 5. And at 3, it's going to be 1 times 3 times 5 times 7. Anybody having a direct way? What's a direct way, an explicit way, Stephen? Yes?
I have an idea.
Yeah, go ahead.
It's like, for 1 we have 3 factorial divided by 2.
So this one, yeah, exactly. So this is 3 factorial divided by 2. Yep.
For 2 we have 5 factorial divided by 2, 2 times 4.
Yep. Mm-hmm.
That's 7 factorial divided by 2 times 4 times 6.
Yes, correct.
For the denominators, we can take 2 from each even number.
Yes, so this is 3 factorial times 2 times 1. That's 3 factorial times 2 times 2. Sorry, 1 times 2. Sorry. 1, 2. Sorry. Trying to write and say different things is not an easy thing to do. 2 times what?
2 times 1 times 2
And,
to the second.
and then what's this one going to be? 7 factorial over 2 times what? 1 times 2 times 3?
That's 2 to the second. That's 2 to the
Which one?
2 to the n plus.
Oh, the second one, thank you. So can we write that as a certain factorial instead?
In the denominator.
2 times, what, 1 factorial? And what's this one? 3 times over 2 times,
No. That's 2 squared, that's 2 cubed. It's the same?
did I write something wrong? Thank you.
Also,
That was lazy. So I factored out a 2 from both of them, so this should be 2 squared, and that should be 2, like this is what you're saying?
Yes.
Yep.
So
Yep.
it shouldn't be 3 factorial. It should be 5 factorial.
Let's take a look at this. Did we? Whole thing goes right there. Summation n plus 1. You got to make sure you put parentheses around the n plus 1. Oh, it depends on where you started. So if it was n plus 1, you're going to start at 1. But it would be n plus 2 if you did otherwise. Okay. And then what is it? X plus 5 to the what power? 1. Oh, what's the power going to be? What's the power going to 2n plus 1? Think so? Something like that? Is that correct? Yeah. Oh, it's frozen. Thank you. like that. And then what's the denominator going to be? In this case, it's n minus 1 factorial, I think. If it starts at 1, I picked 1 to start with. I think that's right. So that's nice. You get an explicit formula. You could then try to find the interval of convergence, but I asked you to do this one instead, 15. So when you did this one, you ended up with, I think, a radius of convergence of being 2. And then you end up with this, right? I think, but what do you have to test? What do you have to test? What do you have to test? Test each one. Endpoints. Test endpoints. You have to test the 1 and you have to test the 5. When you plug in 1, what kind of series do you get? You get an alternating and it gets strictly smaller. It's similar, I think. Let's see here. Very similar, but not exactly the same. Very similar. Very, very similar. You test the endpoints and does one of them work? Yeah, the 1 does. So you end up with this right here. This. Why? How? How does it work? Okay, let's plug in 1. What do you get? If x is equal to 1, n equals 1 to infinity, you end up with negative 2 to the n over 2, like that. Is that correct? So what are the first few terms of that? Plug in 1, what do you get? Negative 1. Plug in 2, what do you get? What do you get? I think you get 2, right? Is that correct? Oh, it's 2 to the n. Yeah, sorry. You plug in 2. It's n equals 1 to the n. Sorry. There. I dropped all those n's there. So I plug in 1. What do you get? You get negative 1. What happens when you plug in 2 to this? What do you get on top? 4 over what? 4 over what? 8. And if you plug in 3, what do you get? Negative 8 over what? You get 3 times 2 to the third? 3 times 2 to the third? 24.
Wait, can you just like...
Yes? No?
Can you just factor negative 2 to the n and then 2 to the n, 2 becoming negative 1?
Yeah, you can absolutely simplify it first. Does everybody see what Nam said right there? You could make this instead. You could simplify to negative 1 to the n, 2 to the n, all over n times what? 2 to the n? And what happens? So you have negative 1 over to the n over n. And is that what you get there? You have negative 1, and then what do you have? Positive half, and then what do you get? Negative a third. What series is that? Alternating harmonic. Does that converge? Yes, it does. But when you plug in 5, does it alternate anymore? No, you plug in 5, it just becomes the harmonic. Does the harmonic converge? No, it does not. It does not. Okay, with a partner, someone you haven't worked with yet. I remember who you worked with.